Oh, is my stream frozen? I don't think so. I think it's alright. Okay. I was having a very hard time getting myself to work on my OS today. So I thought maybe it'd be a good idea to start streaming. Maybe that'll help. We'll see. I don't know how readable my... Okay, that should be pretty readable. I'm using NVIM. And... yeah, if you can't read that, you need glasses, dude. Let me find my source code that I use to cheat from. XV6. Okay, so stacking on this, put that, there we go. How do you switch? Okay, yeah, all right. Ship. Oh, is this font? Nerd font. Oh, nerd font. Saw another version of it that I really liked. Downloaded it on my MacBook, and maybe I should switch to that on here too. What was it called? Clean something? Yeah. Proggy Clean Nerd Font. It doesn't really like that different from this one though. Maybe I should keep this one. And I'll go through the troubles of switching. Anyways. So I use this source code a lot to kind of cheat my way through writing my own OS. Where's the trampoline? Why do we need a trampoline? A trampoline is kind of like an ST vector for user processes. Whatever that means. I've got the mem layout. We don't care about that either. So right now what I have, is this the MMU? That's the kernel. This is the kernel. This is the MMU. That's my definitions file. You've got init MMU. When you call init, it frees up some range and calls kpageInit. What's kpageInit? KpageInit is nothing right now. So we probably need to set up the stack pointer. dedicated a page for the kernel. Let's see how XV6 does it. It should be in Calc. Okay, so take us somewhere. Should use this for searching. And here in Calc with kinit, free range. They use a yacht lock because they have multiple processes. We don't. Got K free. Okay, so now we can search up to see who is using kinit. It's used in definitions. It's not used. It's defined in definition. In main. Okay, main is using kinit. Let's see. Main is using kinit. And then right after that, kvm init. In vm.c. Kernel page table. Okay, it's in VM, kernel page table. Okay, I guess my question would be how to debug RISC v32 QEMU virtual address conversion to physical. See if there's a way to do that. I'm guessing like you could do step I's. My guess is step I's, and every time you do step I, you check the registers. But that's just my guess. Connect GDB, setting breakpoints. Translate address. What is that? Replace translate check with the actual function or place where address translation occurs. Well, I don't know where that is. I thought that happened in the hardware RISC. So yeah, basically what I guessed. So you step and check the registers every time. SATP. I guess there's no way of knowing. Because it's in the hardware. You can't debug the hardware. Not really. Okay, I have to guess my way through. Let's see. We could search the SATP up. See when that is getting changed. Write SATP. Start.c is calling that. Write SATP. Make SATP. VM.c is calling that too. So, okay, start.c disables SATP just to make sure. Delegate all interrupts and exceptions to supervisor mode. And then VM, after it's done, Did I already have VM open? Yeah. After K, VM init heart. KVM init, KVM init heart, which is, I'm guessing, called right after KVM init. Right after setting up the page table. sfence VMA. Wait for any previous writes to the page table memory to finish. How do they do that? How do you do that? It's in RISC-V.H. How do you wait for writes to finish? sfence.vma00. Oh, that's a RISC-V thing. So wait for every write to finish, and then you set the SATP, and then wait a little bit after flush the stale entries from the TLB. Let me search this up. sfence.vma. RISC-V. Is it a real instruction? This website is awesome. sfence. Huh. Matching the address and ASID as executed instruction. Oh. Translations that began while SATP was active were not required to complete or terminate when SATP is no longer active unless an sfence instruction matching the address and ASID is executed. Hey, how's it going? I'm having trouble reading the name. Eddie Jocks Inbill. How's it going, man? Welcome. We're just chilling. We're just coding OS stuff. See if you understand this shit. It's so complicated. I really need to focus. Translations that began while SATP was active are not required to complete or terminate. Well, those things oppose each other, like complete or terminate. They're not required to do any of those. How is it fucking possible? You're the guy I DM'd on Discord. Oh, right. What was it? Sigma? How's it going, man? Is this really complicated, or look at the sentence? Does it make sense? Translations that began while SATP was active are not required to complete or terminate. That makes no sense to me. It either has to complete or it either has to terminate when you change the SATP, because you're changing SATP. But there's no other way. Like it's either completion or termination. So anyways, but you can force a state with sfence.vma instruction matching the address and SAID. Okay. Asset. Is that a real instruction? It's a real instruction, but you've spelled it wrong. Hey, Salsa. How's it going? So yeah, you would want to, I'm going to take a note of that. You would want to write sfence instructions before and after doing SATP just to flush everything. So let's just leave a comment somewhere in our code before changing the SATP. I'm thinking it could kpage init. Where would it happen? We have the initialization for kernel page here, and then we have map import memory to VA, UART, PLIC, trampoline. Yeah, after you map everything to your VA, that makes no sense, dude. Wait, it does. So you dedicate each page. Memory is made of pages, okay? Should I explain this? Do you guys know what paging is? At any point, if it's confusing, just ask me to explain things. I'd be happy to do that. You dedicate one page on your memory to each one of these things because you're switching to virtual memory and not physical memory. You have to kind of virtualize the way you use UART, PLIC, and trampoline. So each one of these will be a page. Right now I don't have a trampoline. But then after that, we're going to have to do SF, what was it, sfence? Wait. Sfence VMA. Sfence VMA just to flush. And then set SATP and then sfence.vma flush again, just to kind of create a barrier wall between before that you didn't have SATP on. Is it SATP? I hope I'm not. Yeah, SATP. And after having SATP on. Hey, Tufo. Or Tuffo. I'm really bad at reading names, I'm sorry. So yeah, you want to have that. Just leave a comment there. Don't forget. Now what else do I want to do? Let's start mapping our stuff, our important stuff. Oh yeah, Tufo. I'm on Pop! OS and I'm liking it. I switched to Pop! OS very recently. I first had a Ubuntu. For the longest amount of time, I was using Ubuntu. But I don't know why, but Ubuntu was having trouble with my Wi-Fi driver. And the firmware on it was not working right. So I switched to Arc. Arc was too much trouble for no reason. It's just a little bit stupid. Controversial opinion. You want to try Arc sometimes? I did. I'm sorry, I don't like it. It's stupidly bad. NixOS user here. Yeah, I read that on your profile. You're really serious about Nix. What's special about Nix? Let's go on a tangent here. NixOS. What's special about NixOS? Advantages of Nix. These configurations can be managed directly with Git, allowing the system to be restored to any historical state. Whoa. Huh. Pretty much everything, to be honest. I don't know what that's an answer to. Oh, what's special about Nix? Or I don't know. It's a declarative distro. The whole OS configuration is handled in a custom programming language. Oh yeah, Nix. That's the name of the language too, right? Nix. declarative builds and deployments. Let's see. I don't get it. What happened there? Theoretically restorable and reproducible at least. Oh, I get it. So now in this video, the user kind of switched to another config with Node.js in it. Is that right? Am I getting it right? It was like instantly, kind of like Docker. It's kind of like having an image of your operating system. You just made a sub shell that has Node.js in the path. Okay. Yeah, that's interesting. Reliable, declarative. Next makes it trivial to share development and build environments. How fast is it? Try new tools without fear, multiple languages. One tool. Oh yeah, that be a heaven for someone who wants to try tweaks on their operating system. Oh yeah, I can see how you'd find crazy mods for your OS, and you can instantly switch to them and kind of like come up with a great dev environment. Damn, that's really interesting. Thanks for introducing that to me. I might try it. I might try it as my next OS. Because I just switched to POP. If the binary is in the next packages cache, it's pretty much instant. It may compile for low use packages. I don't mind a small download and even build. Really don't mind it, but it must be running on some sort of a container. It must. There's no way that it's not. Anyways, let's not get lost here. Right now I'm writing my own OS. It's gonna be better than Nix and Pop OS and Ubuntu and everything else because it's mod. It's not gonna work better, and it's only gonna be able to handle one concurrent process. No container at all. It uses Nix store. Huh. No container. How? It's very tempting. I'm tempting. It's very tempting to research that up. Uses Nix store to store all packages, symlink everything to the FHS system. Oh, symlinks. Still, it kind of needs a VM thing. I mean, every OS has a VM. Did you know that? Did you know that every OS has kind of like a VM running? That's what an OS is. It's basically a VM. It's an abstraction on your computer. This makes it instantly cacheable and also make it possible to have multiple versions of the same package. That is very interesting. That actually solves a lot of problems for programmers. I need to try that. I need to write that down. Try Nix OS on VM. I'll try it on VM, and if it's good enough, I'll switch. Whatever. I'll switch twice in a week. I've done that before. Anyways, let's go back to the code. Set the SAP sfence VMA flush. Okay, let's try and map our important stuff. You can map to UART. I have the map function, malloc, map set, map CPI, map pages. First, we need to write the map function. You pass in a page table. So before that, we need to make a page table. So here, make a page table. I wonder if I've written that function. Also very coupled with the next language. I recommend taking a look. I definitely must take a look. Very, very interesting. Oh, I need to stop talking about it. I was super distracted today and felt very, very, very lazy. I am yeah, I can't talk about it on here though. Maybe I can, because there's only 3 people, maybe 5 more will watch it later. Nobody will watch it to this point. Or how many minutes are you? 1 minute 6 or something? That can't be. Or at least 10 minutes in. It's not a site generator. It's pure code, bruh. But yeah, for the next video, what I'm doing is that, first of all, I'm finishing up my OS. I'm finishing up all the articles for my OS tutorials. And oh yeah, for the site, remind me to, maybe I could do a live and show you the code of my website. It's a trick. It's a trick for styling it. It's actually a funny story. But yeah, for the next video, I want to finish up all the stuff and kind of finish up writing my first tutorial module. And I want to kind of compare my source code to the source code of Linux, which is stupid, I know, but it will give the video some crazy claim, a crazy test to my OS, and maybe you'd want to watch that go down. And for that reason, I want to first finish up the code to my OS, what we're doing right now, and then I'll take a look at the Linux source code, try and see if I understand it. And it's crazy. Have you ever looked at Linux source code? It is absolutely massive. Look, what the fuck is even happening here? Like, if you click, it says I think it's memory management, right? You click on it, there's like 1 million files here for and they're all .c. That means the problem with .c files is that if you want to reference 20 million lines of code, is that right? Is that actually right? So yeah, what I was saying is that the problem with writing code in C is that if you want to reference another function from another file, and we have like, I don't know, 100 different files in here, and we have other folders with files in there too. If you want to reference another file from here, there's no CMA dot name of the function. It's just name of the function. You don't know where that function is coming from. you can't just know which file it's coming from. Like, this might be on the same file, but if it wasn't, like count VM events here, if it wasn't from the same file, you'd have to actually copy, go up here and search it up in the entire source code and find a definition for it that's not .h. Like, these are all calling it. Where's the actual definition? And this might happen too. Like, this one is not actually defined anywhere. I don't think it is. That is crazy. But yeah, you have to actually search it up in the entire source code to find the definition for it. I think everybody should try and, like, there should be an effort coming from everybody to kind of switch to another language and drop C forever, for good. So far, no luck. There's a lot of machines that depend on C, like important stuff. Like, if you're in an airplane and the airplane's cruising, there's probably some C code involved. Something went through the libc and the GCC stuff to get you to your destination safely. So you OC. But it's a shithole. Whatever is written in C is a shithole. It also has nice things though, so I don't know. Who am I to judge C? This is a normal developer. What were we doing? Let's just make the page table, okay? Stop distracting me, dude. First we do a malloc. Everything relies on C. I totally agree with that. Set it to 1. That'd be a good test. Malloc. Let's call malloc ones here. Malloc. Whoa. How'd that happen? What do you need from a malloc? Unsigned int amount. Is that the number of pages? The amount? I don't really remember. I'm not really using the amount. Page size, yeah, okay. Here we do page size times amount. So the mem set free. Right now, there's no amount. The amount does not work. Okay. Just remembering that the amount doesn't work. I'm just going to put 0 in there. Do malloc. What does it return? Does it return anything? It's not even returning anything. I'm just doing a test to see if that malloc actually is being called without raising any interrupts. It's the size and byte. Yeah, but here, what you're looking at is the source code to something made up by me. So it might not be the same as what it should be. You know what I'm saying? We have malloc here. Let's just run it and see what happens. I'll be building my code on my site monitor, so you might not see it, but I'll run it in my main monitor. I'll run it here. didn't mean to run it like that though. I definitely didn't. Go in debug mode, please. There we go. And then open up that rescue GDB kernel target remote. I could break it on main. Where was it? Let's go straight to malloc. Break malloc. Okay, continue. Whoa, it never reaches malloc. So there must be some sort of an interrupt? Maybe not. I remember it took time last time to kind of free up the memory when we're debugging. Yeah, okay. It reaches the code. Damn, it takes a lot more time to free up the memory when I'm debugging. I wonder why. It's a very good question. Might lead up to some incredible knowledge. Knowledge. Oh. Is that better? Oh, not clear. That's a bad habit that I've developed. Sometimes I clear shit that I'm not supposed to. So I have R equal to kmem.freelist. Let me take a look at my code again. Malloc. I've got that. Grab the R, freelist, memset. Let's break a memset. Now in the memset, info registers. In my arguments, I have that. Is that the address of that? Can't be. It's going from the top of the memory, going back to the start of it, right? That is the size of the page, and then what is that one? A2. What is that one? Yeah, I'm setting it to 1. So all the arguments are right. Memset. And I know the memset works too. Malloc. Okay, so my malloc seems to be working fine for one single page, but it's not returning a reference. Here, I need to dereference this. Okay. That's a good start. Kmem run R. Set free list to the next step of R, and we already have R, so and after we're done with the memset, it's not in the critical section anymore. Is this on 2 tabs? Oh shit. Okay. Memset done. Holy shit, what was that? R dot R is run. It has a next. But we removed everything from R. Okay, so we do void. You just turn it into a general pointer and return. I'm not sure if I'm doing something stupid here, but I could test that. I could definitely test that. I could just come here, say void bang page table equal to malloc, and then now we have a page table. We should probably save it somewhere here, like void page table. That's the kernel page table, but I'm gonna call it page table for now. Now that we have the page table set up, we should write the map pages thing. I don't know how that's done, dude. Map. I gotta search it up. Map page. Map pages. It's in VM. I have VM here. Map pages. Sorry. Sorry for old man noises. Okay. If size is 0, panic. We don't care about panicking. Panicking is for children. Okay? We don't panic in our OS. P ground down. VA. Last is VA plus size minus 1. Forever till you hit that break, which is A equal last. Walk the page table. So you're kind of checking that page table is in some sort of a state. If not, you return -1. Wait. There's explanations here. Create PTEs for virtual addresses starting at VA. That refers to physical addresses starting at PA. VA and size might not be page aligned. What? Return 0 on success. -1 if walk couldn't allocate a needed page table page. What's walk? Return the address of the PTE and page table that corresponds to virtual address VA. If alloc isn't 0, create any required page table pages. What? If VA, max VA, panic. Okay, it's run out of memory. What's here? Level 2 equals 2. Level more than 0. Level minus. Okay, it walks the page table. Okay, let me show you. What was it? SV32 paging. Look, on SV32 you have 2 levels, but on SV39, was it? on SV39, you have 3 levels of paging. And the thing is that you have to walk it to find out the final address. So here, this walk thing here will go through the page table and allocate a path for the address that you want. The VA is the virtual address. Okay, equal to more than 0. That means 2, 1. That's 2 levels. Yeah, that's 2 levels. PTE. And guess the address to the page table. And then increments the address by PX, level VA. These must all be here? No, here. It's PX mask. PX, there. Alright. Extract a 3 9-bit page table indices from a virtual address. Holy shit, how does this work? I feel a bit slow today. Explain the above. But fear not, because ChatGPT's here, dude. PX mask. Purpose: this mask is used to isolate the relevant bits from a virtual address that correspond to a page table index. 1FF. So if you mask it with this, what does masking mean? Do you mean an and or an or? An and. So if you and it with that, you take all the bits from the first one, from the second one, and the first bit from that last. You take the first 9 bits. What's the first 9 bits? First, those are shift 2, right? There's a shift here. 9 times the level. Okay, so 9 times the level. VA. You get the virtual address. You do shifts 9 times the level. So then you shift it. Is it to the left or right? To right. But I don't get it. There's still that offset there. It's missing the offset. It should be 12 plus level times 9. Oh, it is. What is that? What is that? Page shift. That should be 12, right? Yeah, that is 12. Right there. So we got 12 plus 9, whatever. Okay, so 12 is for getting rid of the offset. And then if it's level 0, there's no other shifting. If it's level 1, you shift 9 more, and you get it right there. You take the first 9 bits with the mask, with that PX mask, and that means that you have the address to that page. Does that make sense? Just figured it out, but I don't think I'm gonna remember how that works for a long time. Probably for a good reason too. L0, L1, L2. Okay, so we have PX. Why is it called PX? Page X. Like, is it the level? Like page 2? Second level? PX. That's a terrible name for it. It sounds kind of like a secret function of some sort. Whatever. I don't want to think about it. PX. So you get the address from the virtual address. You get the page address for the level that you are on, and page table. Oh, so that address is from the base of the page table? How does that even make any sense? That should be the address of the page table itself. How is it using the same page table address for different levels? Are the addresses to the... I should ask ChatGPT. In the above function walks the table, why two different levels using the same page table are they? I might be wrong. Let me take a look at it. They are. They are using the same page table. So the same page table. The function walk in your code snippet is designed to navigate through your multi-level page table structure, such as those. The walk function explained. Initial check. Okay, loop through levels. Here PX computes the index. Oh, PX is index page index, at which the PTE for the current level and the given virtual address should be located. Then gives a pointer to that PTE within the current page table. A pointer to that PTE page table entry. Here's some funny noises from outside. Let me check real quick. Why is there fireworks? Does anybody know? There's like fireworks going off. Anyways. I thought someone was attacking my house. We got the PTE. So, okay. Let's go in the first page table. Oh, I see. I see now. So this page table address must be switched on every level. Yes, it is. It's being switched on every level. I see. Okay, we need to write a walk function too then. But wait, what does the walk function actually do? It goes through page table, returns the address of the memory. Okay. So we do need a walk. And we need to add it here too. Walk table. Maybe have the base address of the memory, void of the page table, right? Do you need that? What do you get for walk? Yeah, the base address, the page table, the virtual address, and the amount of allocation. What's that? Alloc. If alloc isn't 0, create any required page table. Pages. If not alloc, return 0. If it is alloc, mem set to 0. So it creates it. If you say alloc, it creates the allocation. The page table thing. Oh, no, don't close that. That was close. Yeah. Void page table. It needs to return a pointer to the page table entry. And we need the VA address. And that alloc thing. There we go. We have the page table, we have the VA, we have the alloc. Well, now let's try and walk the page table. We'd go. There's only one level here, so because it's SV32, no, it can't be 30. Yeah, SV32. There's only one level of paging, so there's no need for a for loop. It's just VA. We just have to do VA shift left by look at the format here. There's 12 offset and then 10 bits of shift left. So that's 22. I'm just going to hard code it in. 22. And then reference that PT by that. That'll be the page table entry. Not the PT, right? Yeah, the PT. You go in there in the PT. You go from there to there, and then you go uint 32. You get a pointer to that, call it PTE. And then the page table entry. That's level 1. I didn't mask the 10 bits though. I didn't mask it. Here. For 10 bits. I'm gonna actually grab this. Go uint. Uint 32. Address. And put this in the parentheses and then do 1. Not 1. I can't do 1. Just end it with a 9. uint 32. Yeah. We've got the address. Put the address in there. And we've got the page table entry address. Get pointed to that. Why do I need a pointer to that? Do I? Do I really? I should set the PT to that, actually. And then repeat this one more time. But here, instead of that, you just do 12, get the first 9 bits. And here's a PTE. And that's what we return. You know what? Allocation makes no sense here. I'm gonna remove it. If you need to allocate, do it yourself on your own time, okay? Fuck you. PTE. Now we have a page table entry whenever we walk the table using a virtual address. So let's test that, see if that works. We've got the page table. Now my UART is at my UART is at Shubububi. It's at that address. I want the UART to be mapped to the same address on the physical memory as it is on the virtual memory, so I'll do that too. Do what I just said. Call map map pages. Give it page table VA PA size perm. The perms. No cat like no perms, you can't see that I'm a motherfucking PIMP. Oh, I need to stop pressing that. Page table. Was a VA. Yes, VA for it as okay. UN32 UART address. Wait, I have it somewhere. I must. Yeah. Okay. UART base. UART base. You map it to the same address. For the size, I'm actually looking at the UART. It doesn't really. It's not really using anything. And then that means just one page would be enough. So, one page. That's going to be the size of UART. And map pages go here. First we call walk table. Get the page table and the VA to see how it works. So what we really need to do here is that we set the PTE to PA. Is that how it works? I'm pretty sure I need to shift it to the left a little bit. What time is it? Dude, I'm really tight. I've been very lazy today, so I started streaming. People showed up too. That was nice. We had a nice conversation about NextOS. Also, you guys helped me code some. That was awesome. But anyways, before I leave, I need to test this. If it runs, I can really sleep tonight. I'm setting the PTE to PA. I need to check where that PTE lands. Oh shit, I'm getting a bunch of errors when building it. What am I doing wrong? So my first error is in walk table. I'm getting a bunch of errors in walk table. Conflicting type for walk table. Void. Wait, malloc. My malloc here has that signature, but not here. So let's change that. Oh, also I removed that alloc part. That's why it's conflicting. Is that why? I'm still getting a bunch of other errors. Invalid use of void expression. 130, not here. 113. PTE equal to PA. Why am I doing that again? Oh, okay. You can't set a void pointer to whatever you want. You have to change it to UN32 pointer. PTEP equals to UN32 pointer of PTE, and then PTEP could be PTEP could be equal to PA. But the problem with that is that it might not be aligned on the memory, like PTE. Because if you're using void pointers, it might land on a byte aligned section, but not a 32-bit aligned section. We'd need to check that. We need to make sure that it lands right on the memory. It's aligned. Invalid use of void expression. Where am I using that? 125. Why is that invalid? PT address. Oh, I don't actually need it. So it is already a void. Yo, what? Void value not ignored as it out to be. Redefinition of address. The fuck's happening? I'm redefining the address here. Okay. I don't need to do that. What else? I'm doing that again here. Okay. Mr. ChatGPT, please help me, please. What am I doing wrong here? Oh, Jesus. Void value not ignored as it ought to be. Oh, I need to dereference it. Dereference. 3FF. Extract bits. Three F. Oh yeah, right. We need 10 bits of it. Okay, good thing. Good thing we saw that. That could take a long time to figure out. We need that. What else was it? Table. Okay. So we do UN32 table. UN32 table PT. Instead of this, we do table. So what ChatGPT suggesting? Yes, sir. And then another cast here as well. Okay, that makes more sense. And then here. Void. I cast that to void now. Ooh, I have to actually put the entire thing after it in parentheses too. Otherwise type get fucked up. Is that true? That can't be true. You're messing with me. I'm still getting a fuck ton of errors. The same spots. Subscripted values, neither array nor pointer. What? Oh, something in my eye. Oh, fuck. Dude, don't be dumb. Don't be dumb, man. I'm still getting warnings, but those are just warnings. It says assignment to PTEP. So PTEP is a, what is PA? PA just a U in 32, but PTEP is, so we need to do that. That was a good warning. Very, very useful. The other warning is saying that in map pages, implicit declaration of function map pages. On line 29. 29. It's not implicit, I already defined it here. Didn't I? Oh, I didn't. Sorry. Dude, I'm sorry. Map pages. Map pages, man. We need that here, dude. My man. Otherwise, it's implicit definition, bro. Too few arguments to function map pages. Okay, so I'm not doing the perm. Good. Good bunch of warnings. 0. For now, 0. Okay, there we go. Compiled. Now, I forgot how I was supposed to test it. I guess we'll figure it out. Let's run it here. Go back, dude. Go back. Go to GDB. Map pages. It's gonna take a long time to free up some memory. Don't worry, it's not an infinite loop of exceptions. Okay, there we go. Map pages. Page table address is at FE4A0. Towards the end of the memory. Okay, that makes sense. The virtual address is that I'm setting it to, okay, let's see, print XVA. Yeah, okay. That is correct. I'm sending my virtual address to the same physical address. They match. Size is 1, perm is 0. Now, where is map pages? Okay, now the moment of truth. Walk table. Brick on walk table, dude. And then continue. Now it reaches walk table. Okay, this is getting... I have a little bit of a headache. I really want this to work so that I can leave and go to bed with calmness without having to think about what is going wrong in this code. I have PT, the same address, that's correct. Virtual address is the same. Now let's see if it can walk my page table. I might have to write it down to make sure. Let's do that real quick. Tab new notes.txt, okay? So where is that? That's my page table. Step by. Print table. Step by. Print address. Address 0. Yeah, because it's just a bunch of zeros, right? I guess. The virtual address is very, very straight, so. Unlike June. Step by. That was a complicated thing. Print X table. Whoa, what happened to the table? What did it move there? There's something going wrong. So looking at the value of the table? What? That's not how it's supposed to be. Oh God, kill me. Oh. What is it doing wrong? 1, 2, 4 table, walk table. I'll run it one more time. Jesus fucking Christ, man. You just fucking work, dude. Whose stupid idea was it to write a fucking OS? Just use one that exists already, okay? PT. Now I set the table to PT, okay? Print X PT. PT is pointing towards the end of the memory. That's where my page table for the kernel is. That's okay. But look at the table. Print X table. Just looking at the same address. Now we're setting the address to print X address. It's 0. So, okay, look at this part. Table, just to make sure, X table. Okay, table is pointing at that part, okay? Address is 0. So table and address must be the same as table. So this statement should not change the value that's sitting in the variable table. Is that correct or not? What am I understanding wrong? What the fuck is wrong with this? If I go next, print X table, it's pointing at this weird value. How? Why? Dude. I don't get it. It makes absolutely no sense. Maybe ChatGPT could help me. Let's see. Let's see if I'm missing anything here. Thank God for the existence of ChatGPT. How? Address is 0. What is table address? Change the value of table to 0x101010 Oh, dude. Table. Operation misunderstand. When you do your attempted to access the entry at index 0 of the table, which is pointed to by oh. I see. I see the crystal raindrops fall, and the beauty of it all was when the sun comes shining through. Bang. Oh, just the two of us. Map pages. Okay, so when I'm creating that page table, I'm not clearing it. So that page table has some values in it that are pointing to the wrong direction. They're pointing to the wrong pages. So my second level of page tables are not initialized. Right. Okay. I see. Alright, that's enough for me. That's a good resolution for tonight. I should add a to-do here at the top. To-do. Second level of page tables are not initialized. So the walk table function doesn't really work. Bang. Alright. That's it for today. Thanks for watching, everybody. Yeah.